Blood transfusions were performed way back in 17 and 1800s. However, they were almost always fatal. This is due to the fact that blood types were yet to be discovered. Blood types were finally discovered in 1901. Carl Landsteiner was the first to discover the modern blood types known as A, B, and O in 1901. His work earned him a Nobel Prize, and 2 years later, after further testing, Landsteiner discovered type AB. Type A positive and O positive are the most common types of blood in the United States. Approximately 72% of the population are one of these two types. Type AB- is the rarest blood type in the United States today and makes up only about 1% of our population. An individual's blood type is inherited from both parents. The ABO blood typing system commonly used is controlled by a single gene found on chromosome number 9. This particular gene has 3 different allele possibilities. Alleles A and B are codominant, while allele for O blood type is recessive. This means that a homozygous dominant A parent who breeds with a homozygous dominant B parent produce children who are both AB dominant and express both alleles. When both parents are O, the result is the offspring can only be O as well, as this is a recessive gene. Similar to the ABO blood type system exists the Rh factor, which is also controlled by a single gene and inherited from both parents. However, in this gene there is only 2 possible alleles, positive for the Rh factor or negative for the Rh factor. 2 major concerns about blood grouping hereditary exist: ABO hemolytic disease or Rh disease. A child is conceived by parents with 2 varying blood types, for example, AO and OO. The resulting child is AO genotype. Complications arise during pregnancy when the child's AO blood type becomes mixed with the mother's O blood type. The mother's immune system does not recognize the child's blood because of its different phenotype. The result is the mother's immune system attacks the child's blood. Rh disease works in a very similar manner, except acting upon the Rh factor and antigens on the outside of the red blood cells. Treatment to prevent these complications include early screening of children's blood type, injection of anti-Rh antibodies into the mother, and destroying the foreign blood before her immune system can discover it. Much of today's medical care depends on a steady supply of blood from healthy donors. Millions of accidental victims, cancer patients, hemophiliacs, and surgery patients receive blood transfusions every year. In fact, 4.5 million Americans need a blood transfusion each year, and someone in the world needs blood every 2 seconds. This is why advances in blood safety and control are so important. In order for this process to work, the agglutinations or cellular markers on the surface of a donor's blood cell must match those on the surface of the recipient's blood cells. If blood of a different type is introduced into a patient's body, the patient's antibodies will react with the antigens on the surface of the donor's blood. The result is what is known as agglutination of the blood. Agglutinated blood is unable to carry oxygen or nutrients to your cells, or carry waste and CO2 away from your cells. Agglutination will also cause cracking of the red blood cells, and thus loss of function. When a red blood cell cracks open, hemoglobin leaks into body cavities, which cause toxic reactions, and often death. Agglutination is most likely fatal, explaining why early blood transfusions performed in the 18th and 19th centuries were unsuccessful. Luckily, significant advances have been made in blood safety over the past century, particularly within the last 20 years. Currently, the most severe risk during blood transfusion is administrative error. This shows how far advances in blood safety and transfusion has come.